Good morning. How is everyone this morning? My name is Beth Gallick, and I'm the Executive Director for the Bay Area Manufacturers Association. Before we begin, I'd like to go over a few housekeeping items. If you're having technical difficulties, please click on the square with the question mark found at the bottom of your screen. You can also email admin@bama-fl.org if you have any questions. My team and I will be interacting with you through the Q&A box, and make sure you pay attention throughout the event for opportunities to win a 3D printing voucher at AMRoC Fab Labs. I'd like to welcome Armwood High School, who is joining us today. Please make sure you ask your questions through our chat feature. We would love to hear about all the questions you have for our presenters today. And I'd like to tell you a little bit about BAMA. We are an industry-focused membership organization serving the manufacturing industry here in Tampa Bay. Our mission is to support manufacturers and promote economic development in the Tampa Bay region. We're the official representation of the Florida Makes Network in this region. And through this affiliation, we help manufacturing companies in a lot of different ways. We help expand market opportunities, develop customized initiatives, adopt best practices, and assess opportunities for state-of-the-art technologies and training. Our solutions are designed to help companies address current challenges, create new opportunities for growth, and achieve measurable results. Additionally, we serve as advocates for the industry and for promoting advanced manufacturing careers. We are here today and happy to help change your perception of what it means to work in manufacturing. With that purpose and in celebration of Manufacturing Month, we're hosting free virtual events and activities for you to engage with throughout the month of October. So make sure you check back to our Manufacturing Month Hub often, because we're adding new tours and events daily. Today, I'm very happy to be here with Terry Willingham, who is the Executive Director of the Foundation for Community-Driven Innovation, which created and runs AMRoC Fab Labs. AMRoC, which stands for Advanced Manufacturing and Robotics Center, is a public creative space based in the University Mall in Tampa. It's a pretty cool space. I've been there myself. So today I'd like to start out by asking you, Terry, why is manufacturing so important to you?
Well, I think it's a key to everything that, makes our economy hum and gives us all purpose and the ability to be useful and productive. And we manufacture things at both large and small scale. So AMRoC is a little bit more about, the smaller scale manufacturing and the educational processes that lead to a skilled workforce. And I think we'll all agree that the more things that we can make locally and that we have the capabilities of manufacturing ourselves, the better. And so at AMRoC, we celebrate that creative spirit at the most fundamental level, which is everything from teaching very small children different technologies and becoming technically literate to workforce skills for adults. And we do that with accessible tools in the community. So I think it's a vital skill. I think it has as much to do with personal fulfillment as it does with economic development. And we're really happy to be able to provide that agency here at AMRoC.
Thank you, Terry. We're so happy to have you and have that available. Now, before we begin, we'd like to find out a little bit more about who we have with us today in the audience. So use the Q&A box and let us know who we have out there. What schools are out there, what grade levels, and or maybe what company you're joining us from, so that we can find out and interact with you. And don't forget, please ask those questions throughout the program today. Now is your opportunity to interact. So ask away, and you might even have a chance to win a 3D printing voucher. So let's get moving and find out a little bit more about AMRoC Fab Labs. So Terry, go ahead and take it away.
All righty, well, we're going to try sharing a screen. We did it earlier. We're going to see if our video tour of AMRoC will work before we launch into our slide deck. So I'm going to share my screen and show you a little bit of what AMRoC looks like for those who haven't been here. So bear with me here. Okay, let's see. All right. Let's go back to the beginning here, shall we? There we go. To show the different processes. I'm from the camera yet. See if anybody notices the hand on it. So that was the sort of flyby tour of AMRoC, and I'm going to tell you a little bit more about some of the things that we do here and cover some of the things that you may have seen. And hopefully you can ask us some questions too about some of the things that you saw along the tour. Hopefully I got it all covered here. But as you can see, as Beth said, the Advanced Manufacturing and Robotics Center Fab Lab is a public fab lab, like a makerspace located at University Mall in Tampa. And go ahead and you can go to the next slide there. So there's our mission, right? So basically we're trying to support academic achievement, economic development, and innovation through a lot of hands-on stuff. So you won't find a whole lot of classes here, but you do find a lot of experiential learning through robotics for all ages, 3D printing projects, We just starting an advanced manufacturing competition, so a lot of competition-based learning as well. Right now, we're open by appointment only, as a lot of places are, but you can go on our website and use our scheduling app to come for tours and visits, and we require face masks. So we do have groups meeting here and working together. If they're not sitting at individual tables and everybody is obviously wearing a face mask, we want to keep everything safe and healthy while we continue being innovative and productive. So you'll see us wearing face masks here as well. I'm not wearing one at the moment, but the other folks who are here with me, who, when we're working close together, will have them on. So these are some of the different things that we do at AMRoC. You can explore science and tech. There's a workshop in back that you saw. We have a lot of design and fabrication and prototyping tools. We have the robotics and experiential science and tech, and we do entrepreneurial support and networking as well. We have an entrepreneurial program here for ages 16 and up, which is a very early stage entrepreneurship program that we started recently, where people can develop an idea. It's a 16-week program, and they can earn seed funding as they go through the program. So we're really excited about that one as well. These are some of the things, the services that we offer. So as a nonprofit, typically, traditionally, nonprofits depend on grants for sustainability. And one of the things that we're trying to do through AMRoC Fab Lab, which is created and run by the Foundation for Community-Driven Innovation, is having a number of services that are revenue generating. So that includes things like memberships, pre-COVID anyway, where people could come in and use the facility, and we're about back at the stage where we can do that again. Professional development for educators and manufacturers. We do micro manufacturing services, and we're actually going to talk a little bit about some of our fabrication and 3D printing services in a few minutes. If people can rent the space, we do educational support services. We have some retail services with a small storefront up front that we're going to be adding some equipment to soon for robotics and other things. So we have a number of different ways that we can earn some revenue that we can generate through services and put back into the Fab Lab. These are some of the equipment that you saw when we did the video tour. So these are a number of different things that we can use in back. We're getting some new equipment as well. But right now we can do a lot with the things that we have on hand. So you saw the sewing machines. Those are a recent addition, and we can do a lot of things with that. Our programming this year, these are just some of the things that we've done. Automotive repair and training certification. We do science and tech talks. Obviously, manufacturing day tours. Last year, it was fun to have people come through the Fab Lab in real time, and we'll do that again in the future. And robotics camps and programs like that as well. And we've served over 300 area residents ages 6 and up in the last year. So we're very excited and happy about that. So we do have a number of things underway right now. We actually have openings on our high school robotics team and our early elementary robotics teams as well. The Equity and Entrepreneurship Program enrollment is ongoing, as are our automotive repair certification test courses, and a variety of online and on-site programs. We're starting a drone program here, specifically the VEX virtual reality drone program. So we're opening that one up, and that's a high school and up program, and the advanced manufacturing program as well. And these are, I think we've got some photos here and some other images about the different things that are in AMRoC. We love this mural. You can see it behind me. And you'll hear from Marissa Sherrick shortly, and she is our AMRoC First Vista. Her uncle painted that. He's a fantastic artist. There's a lot of art here because we believe art is an integral part of science and technology. There's an art to programming. There's an art to design. There's an art, if you do it right, to everything that you do. So we're really excited to represent that here with some terrific work from local artists. One of the things that we did when COVID happened was we pivoted to provide personal protective equipment. That's one of the first things that the sewing machines were used for, is we made masks, and we also use the 3D printers and other resources for making protective face shields. And so with a community partner, we do a lot of things in collaboration with community partners, and with a local community partner, we helped produce and distribute over 40,000 face shields since March that have gone out to local healthcare providers. These are some of the other things I spoke about. Registration's open now for our high school level robotics competition team, and as well as for our other programs as well. And the Equity and Entrepreneurship Startup Studio. We're really excited about this program. As I said before, this is for 16 and up, although we did let a 14-year-old in who's got a fantastic company that she started. And that program actually starts out with Small Business Development Center Idea Camp, where you learned about the entrepreneurial mindset, and it caps at the end with the 1 million cups presentation and the award of seed funding to get your business off the ground. We also do the automotive repair programs and consumer auto care. We have a few talks that we do each month. This is one of them on the third Wednesday. These are virtual right now. So if you're interested in learning how to take better care of your car, this is one of the programs we do. We also have a First Fridays at the Fab Lab talk. Both of these are broadcast on Facebook Live. And you can tune in and listen to them. And they're all on the calendar at the website at AMRoCTampaBay.com. A little bit more on the courses. You can kind of flip through these. I think they're just little slide overviews. These are just photos of some of the different programs that we do with the robotics programs. This actually, the picture at the bottom left there was Shields Middle School visiting during manufacturing month last year. And these are, again, some more of the programs we do. There's BattleBot down there at the bottom left, and that one is actually in California right now competing. And so USF students come over with different clubs. I think this was the Society for Electrical Engineers. We also have NSBE, which is the Black Engineering Society, and Hispanic engineers, and a variety of other groups that use the facility here for their meetings and to work on projects. And we have a lot of tool use, so you'll see some of the students there in the shop actually learning to use drills and things like that. And everything is guided and gives everybody an opportunity to get some hands-on fun and build stuff. And again, some of the things we have, those are some of our 3D printers. We'll get a closer look at that in just a minute. And then what you can do with membership. So anybody who has a membership here has access to, with training and orientation on the shop, has access to all the tools and resources, the 3D printers, and the workspaces and classroom spaces. And these are folks working on projects. 3D printing, we're going to go look at that too. These are some of the programs we've been doing. So obviously with COVID, we've switched to a lot of online programming. So we've done professional development online, programming classes for students, and a variety of different displays and things to provide some other ways to interact with the space. That's our workshop in back there. And that was our last big gathering in February when we did a ribbon cutting with the Uptown Chamber of Commerce. The space is here and available to everyone, and we look forward to opening it back up again in the near future and having some more folks being able to come in and join in and do things here. But in the meantime, we continue to be able to provide a lot of resources, and some of those we'll look at more closely in a minute. And there's our website and our social media. And I think that's it. If anybody has any questions about anything before I turn it over to Marissa so you can get a closer look at some of our robotics programs, please let me know.
Sure. Thank you, Terry. Thank you, Terry. Our group found something on your tour that looked a little out of place.
Oh, did they? What was that?
A little shocking. Could you go into what that was?
It depends on what they saw.
It looked like a part of the human body.
Okay, so what we were wondering if anybody would notice, so that's actually our safety hand. And it was part of a prop display that had been created here for something else, and it took up shop over by the bandsaw. And if there's anything that'll remind you to be safe around equipment, maybe dismembered. It's just been left there as our own Easter egg, and it's a good reminder that, you know, the tools can hurt you if you don't use them properly. So that is why that's there.
That's a great lesson. Are there any other manufacturing-related youth programs that you have at AMRoC?
I'm sorry, can you repeat that? I'm sorry.
Sure. Are there any other manufacturing-related youth programs that you offer at AMRoC other than what you've mentioned?
Yes, we're actually a pilot study. We're running a pilot program here for the VEX Advanced Manufacturing Competition, which is actually a competition to create a work cell. We're beta testing the equipment here with a number of students, and if there are students who would be interested in being part of that beta test, they can contact me. You can reach Beth, and she can give you my info. You can also reach us through the website on the contact page. And we'll be running that program through December, providing feedback to the Robotics Education Competition Foundation before they roll it out to the public around the first of the year. The other programs we're doing are the drone competition. So we're participating in a virtual drone program, which is going to be mostly done through Python programming, as well as actual on-site program. We applied for some funding for that because it's a little bit more expensive to do the actual paradrones competitions, but that's another one we'll be starting as well. We have a variety of programming classes, and Marissa will tell you more about our first programs in a minute.
Okay, that sounds very exciting. Thank you. Thank you. Mm-hmm. And don't forget, keep those questions and comments coming in throughout the program.
Okay, I'm going to turn it over to Marissa Sherrick, and she'll tell you a little bit more about herself. So I'm actually going to flip the camera around so you can see her. Marissa is our AMRoC Vista, and she'll tell you what that is and show you some of the robotics things that we do here on site.
You see me and all the robots?
Can you hear her okay?
Yes. Hi, I'm Marissa. So I'm AMRoC Vista, and so my job is to help underserved communities get out of poverty through teaching their youth STEM education. So how I do that is by working with the FIRST robotics program. Well, first, the organization. So FIRST is for inspiration and recognition in science and technology, and it's all about inspiring students ages 4 through 18, pre-K through high school, to learn about STEM education, engineering, robotics, electrical, programming, all the different forms, mathematics, and to give them a motivation and passion to continue researching and learning these skills throughout their life. And I have many robots in front of me. So there's 5 different robotics programs. So for our 4 through 6-year-olds, they have the First Lego League Discovery, which is mostly just inspiring students, these kids, to just start thinking about engineering processes and just getting them excited to create things. And then we move on to our First Lego League Explore, which we use the WeDo robots, and it's a simple programming. It's Scratch programming. It's a drag and drop. It's very easy. Kids pick it up within an hour, and I've taught almost every level of FIRST. So very good. These are for ages 6 through 10. And then we move on to our First Lego League Challenge. So this is the real competition. It's our largest program for ages 9 through 16. It's a very large group. We had almost 40,000 teens involved just last year alone. And it's all about teaching kids actual programming. We use MATLAB, just simple block programming. So kids pick it up within probably 6 hours, even less. And it just teaches them how to start building, programming. And in this challenge, they have to do a research project. So they also have to research a problem in our world. Usually each season has a different challenge, such as this season is about relay play. It's all about getting out there and exercising. And a lot of these kids have to research ways like, why do we exercise? how do astronauts exercise in space? So it's getting these kids not only thinking about robots, but how STEM education helps everyone in the world. And then we move on to high schoolers, which technically you can start this in middle school too. So our middle school and high school program is the First Tech Challenge. And this is a much bigger robot. This season starts around September and runs till April. And it's all about teaching kids to think. These are the kids that are CADing, they're learning machine skills, Java-based programming, they're using phones. And these kids, these are the high schoolers when you get them really interested in finding what their passion is in the STEM fields. Many students have come back from the First Tech Challenge and First Robotics, which you'll see, and they come back volunteer. They go to colleges. There's over $80 million in scholarships for kids who participated in a FIRST program. And that's what we were trying to do, what I'm trying to do as a Vista, is give these kids a pathway to higher education, or even with manufacturing, trade jobs. These, for our next robotics challenge, can they see it?
Yep.
Awesome, which is the first robotics competition. So this is a lot of machine work. I know a lot of students who've come out of this program and they went to machine shops, they become mechanics. This is where the students find their passion for trade jobs, for manufacturing. This is exactly why AMRoC is here. It's to help students find their passion for continuing manufacturing education. And so as you can see, FIRST ranges all ages, all types of STEM education, and we're very lucky to be here at AMRoC to have almost every single program in one location for these students. And how many students have we gotten?
We're serving 50 just through our in-house programs.
50 just in-house programs. 50 students, and it is amazing, and I'm so happy to be working here with Terry, who's so welcoming and excited to get students involved in the program.
See if anybody has questions.
Yeah, does anyone have any questions that I can answer about the programs?
Give her a minute.
Yeah, I'll just talk. Anybody can start a team. We're a community team here. You can start a school team. There's class packs if you want to make this
Armwood
a class.
High School.
Yeah. Yay.
Armwood needs a program.
It does. We're always looking to start programs at different schools, and this helps.
This is a good year to start too. I'm going to throw that.
Exactly. So I know with everyone thinking about COVID, like how do we meet? Well, a lot of students are doing this online. You can program virtually. You can CAD. A lot of students are doing Zoom meetings.
Registration is lower.
And registration, the cost is, they're lowering the cost for teams because they want to get students still involved. Like just because we can't meet doesn't mean you can't learn. We're still having, for First Lego League, they're actually doing virtual competitions where you'll just videotape your robot and be showing judges and the referees how you complete the challenges.
Which we'll do a lot of Roboticon too.
Yep, and we'll also be having Roboticon that we mentioned. Terry mentioned that. But first, almost every program will be like shown at Roboticon. You'll see the different competitions and how students have completed challenges. And this is a real way to see what the first competition style is like in a traditional sense. And that's what FIRST is all about, inspiring students to compete with robotics in like a traditional sports type with winners. And we're all winners because we all focus on gracious professionalism. So we all want to be winners and know that at the end of the day, eventually these students will be working together in the professional careers.
Did anybody have any questions for Marissa?
Is there any questions?
Because I can't see them if there are. Okay. All right. Well,
I don't see anything that's come in yet.
All righty. So we're going to continue on here. So some of the robot, and actually none of the ones that are in the view right now have them, but we actually do the 3D printing for the youth robotics as well. And so the 3D printing is a big part of what we do here. I'm going to turn the camera back around and bear with me on the trip there. So you'll see with us is back there is Chris Wellingham. It's actually my son. He's a programmer by trade. and he does runs our 3D printing program here to a large degree at AMRoC. And he can tell you a little bit about a project. So we've got a variety of different things here. There's a couple different types of manufacturing, at least. There's additive and subtractive, which are the two basic types of manufacturing that we do here at AMRoC at a sort of micro manufacturing level. That doesn't mean we're manufacturing really tiny things, although sometimes we are. But in our case, micro manufacturing, and in many cases, is simply manufacturing at a small scale level. So there's big plants like some that you've probably seen this week that are producing, everything from parts and aviation equipment, glassware, a whole bunch of different things, plastics. And then there are smaller manufacturing runs, places that can do small manufacturing runs like AMRoC, where we can produce things 3D printed or small machine parts. And so here's a couple of things. This is actually 3D printed face mask that somebody was working on. It actually goes inside of your face mask, and you can put a filter in it, and it adds an extra component of safety. And then Chris is going to talk to you about an interesting project we've got. A lot of people will come with a problem or a challenge, and this is a product that's sold locally by a company, and it's actually called the Santa Spray. It's actually a disinfectant. Oh, and I accidentally turned it on. It's a Santa Spray, so it actually sprays disinfectant cleaner on a variety of different things. And the company that sells it was having a problem with these. They're manufactured somewhere else, and he'd sold a lot of them, but they were having problems. And Chris can tell you a little bit more about that. I'm going to get out of the screen here, and then we'll give you a close-up view at some of the work that he's doing, and he can talk to you about the problem. So we've got about another 15 minutes or so there. Chris, take it away. So if you want to, you can take your mask off if you'd like. I'll step over.
Yeah, so hi, I'm Chris William.
So they can hear you.
Oh, yeah. Yeah, so as Alan just mentioned, so yeah, the problem. Okay, sorry. Yeah, so basically somebody came to us with this device. It had a couple. It's a device that's actually already currently being manufactured at a large scale at several different factories in different locations, as far as I know. And there were basically design flaws in a couple of the parts, right? One part was actually on the electronics side. That was what he originally came to us with. There was like a, some issues with charging, some of that stuff. The main issue, though, was actually with, I don't know if you can see that part. This part here, actually, which is essentially the top of, let's see if I can get this. It's what basically a bottle that holds whatever type of sanitizer you intend to use actually screws into, right? And the problem was that it's basically not very well designed. And what would happen is when you screw in the bottle, if the client screws in the bottle too far, then the top of the bottle cracks. And this is chopped in half, but what actually happens is the plastic splits at a weak point. So the challenge was we had to come up with a way to, find a way to basically make a better version of this part in a way that could actually be manufactured at a low cost, at high quantities, in very short notice, because we actually basically this was an existing product with a lot of things a lot of parts being returned because of defective stuff, right? So
I'll move the
what we
camera
ended up doing was,
I can bring the camera around.
Oh yeah.
Mm-hmm.
But what we ended up doing was, in the end, with 3D printing and all our capabilities here actually comes in is, the first most useful part with 3D printing is in prototyping, right? So within a day, we started getting measurements, took this out into took the original piece into the back room, put it on bandsaw, cut it in half to get a side profile of it. Took out calipers, started measuring different parts of it, built a close representation of the model before we even got the final CAD and the original CAD drawings from the factories. Once we got the CAD drawings, we were able to tune up the CAD drawings a little more, and then started designing reinforced versions of the part. Right. So the solution and the problem with the original piece was basically just the corners were too sharp. Is really that simple, right? So the solution was literally just rounding the corners, right? But then because of short notice and the timeline we needed to actually get these manufactured, we're just 3D printing these. Well, the design isn't really ideal for 3D printing. So when we're done 3D printing, it actually comes out kind of like this, right? So we have all this what's known as support material, right? And it's something to keep in mind if you ever want to get something 3D printed, when you're doing injection molding or something like that, then you're designing for injection molding. You have rules you have to follow when you're using that design, using that manufacturing process, right? When you're 3D printing, there's a whole different process or a whole different set of rules. Some of them line up, some of them don't. But the main thing is if you have parts that are, printing basically, in the end, a 3D printer is, it's just extruding a small amount of plastic in one area, and it can only put plastic on top of on top of more plastic. Actually, we have one printing over here. You can kind of see how it gets manufactured, right?
I don't know if you can see it. We'll try.
So you run into a problem when you have complex parts that sometimes you don't have material to print on, so you have to print what's known as support material. And actually, you can kind of see it's printing support material. Actually, yeah, it's the whole thing's support material right now. But yeah, so in the end, it ends up coming out like this, right? You have to remove, most of the support material, and the end result is actually that, right? Not the best quality, but this is kind of the first step in trying to in determining that this design is the correct dimensions and manufacturable, right? The next step is to actually come up with a way to scale up manufacturing enough for what the client needs, right? And tune in dimensions and stuff like that. So the nice thing is with 3D printing, we can basically determine that this part will work before we get to any kind of larger scale manufacturing, right?
You also did some on the resin printer?
Yeah, so
don't know that you can see it, but we have a couple of different types of 3D printers, one of which is a resin printer, and it prints in a different fashion. So these are FDM printers that you saw over here. So this one that's running layers plastic from the top and builds it up. And the one that Chris is at over here is a resin printer, and it uses obviously a resin. It prints differently. So this is actually a resin print here. I don't know if you can see it. There's a lot more detail in them, and they actually print upside down, and they come through the machine. You can see Chris pulling it out there. And it's a different process. You can bring it closer so they can see.
Yeah. So the resin prints much higher quality. These can pretty much be used for production in many cases. If it's done well, if it's done very carefully, you probably wouldn't notice the difference between a resin print and injection molded part, or even or CNC manufactured. It is generally it's slower, but you can print a higher quantity of things at once sometimes, depending on the manufacturer. Depending on the part. It prints the entire layer all once, one after the next, so you can print, 5 in the same amount of time that you can print 1.
How is the resin hardened? What's the process for it?
Yeah, so it's actually cured by ultraviolet light. So basically, the way it works, it shines an ultraviolet light through a what is it? It's like a
A screen?
yeah, basically
screen.
it's literally a screen. It's so basically just shines a pattern of light one layer at a time. New pattern for every layer. The printing resolution on this is 50 micrometers on here versus I think it's like 200 for a regular 3D printer, for a Fusion FDM 3D printer. And the quality is usually pretty good.
So it has to be cured now, right?
Yeah,
So.
the process though is a lot more. So with this, we have to go through, I'm wearing gloves here because it's generally, it's not exactly safe to handle, like you can't just pull it straight out of the printer and immediately start using it. After you pull out the printer, you have to, put it in basically an alcohol bath to clean off the excess material, and then you actually have to cure it more because it's actually still soft right now. This literally just came right out of the 3D printer. You have to actually put it into a, basically put more ultraviolet light on it, basically, to finish the curing process. And yeah, that's pretty much it.
So, I mean, you can see he's going to keep working with that. You can see some of the struts on there and things like that. This was another piece we had resin printed recently. This thing is huge. It's actually too big to cure in the equipment we have. So this stayed out in the sun for 2 days because ultraviolet light is ultraviolet light. And so I hope it looks like we're a few minutes left here. I hope this gives you a somewhat better idea of some of the processes that we use here. I can take this off for a moment so you can hear me better. And so the 3D printing is really, really useful for prototyping, for testing things, and for more quickly troubleshooting, obviously. So this process, without having 3D printers, without having this facility here, it would have been really hard for this company to figure out exactly what the problem was with their product. So does anybody have any questions about any of that? I know there was a lot of information there.
Yeah, that was fascinating, Terry. Thank you. And thank you, Chris. How long does it usually take to 3D print something?
Let's use this for example.
Yeah. So that particular print, that one took an hour and a half, actually. Actually, no,
this one?
Actually, with supports, that iteration took 2 hours. The next iteration, with a few adjustments, to make it a little more optimized for 3D printing, took an hour and a half. So it does depend a lot on the part and on how you design it. The more you can optimize it for 3D printing, usually the less amount of time it'll take and the better quality you'll get.
Yeah. And the resin printer for the same size item, how long did that take?
That took about 2.5 hours.
A little bit longer.
It literally just takes longer for each layer because, and it takes more layers, right? But the quality, it comes out better.
Yeah. Yeah, so I think people they tend to think of 3D printing as a really rapid process. It's a really slow process, and especially the more detail you work into something, the longer it takes to print.
3D printing generally works best for when you're dealing with, when you're trying to make higher quantities of things. It works best for very small things. Like I wish I had something there, but there's the smaller the part, the less time it takes, right? So,
everything we have right now is big.
Some of the students would like to know how they can learn to design for 3D printing.
Okay, so what do we use to design? You want to bring your laptop over real quick? So what are you using, Fusion 360 or?
I generally use Autodesk Inventor for my CAD tool, but the main thing is, if we don't have them, I should actually transfer some resources.
If you turn your camera around, your computer around. Yeah. So flip that up so you can see the screen better.
Oh,
there you go.
You might be able to see it.
I don't know if you can or not.
I don't know if you guys can see it. Yeah, and do we actually have any resources on that?
Yeah, I can
Like,
send resources. Yeah.
Because
So you can see the design he did there. And
regardless of what kinds of what tool you use, whether you use Inventor or you use Fusion or you use SolidWorks or whatever, the the rules are pretty straightforward because it's mostly just think about what direction you're going to print something, and then
can you bring that a little closer?
Huh?
Bring the computer a little
I can
closer.
try.
Yeah.
Sorry. This computer has a terrible battery, so I'm trying to move
That's fine. That's good. There you go.
Yeah, it's in a way, I guess I would say the best way to really learn this stuff is try stuff, right? Because you put something in a slicer. By the way, there's two tools to this. You have the CAD tool itself, which can be whatever you prefer, Fusion 360 or Inventor or SolidWorks or Onshape's another good one. Then you have the slicer, which for your, depends on what 3D printer you have. My preference is usually a tool called Ultimaker Cura. And usually you just want to design it so that the amount of, you can actually see on here that different colors represent different types of lines or the kind of like the purpose of each kind of line here. The blue parts are support material, and then the red and yellow is the actual part, right? So you want to basically get as little blue material and try to make it
right. So there's any kind of CAD programming that anybody learns that you're learning in school can be translated into creating for 3D printing, and you use a slicing tool to convert the code into something that the printer can understand so that it can do the job. Hope that helps a little bit. There are a lot of tools available. Most of Autodesk Inventor stuff is available free to students. It's all that is out there in Fusion 360 as well.
Okay, wonderful. And do you think it's worth it for students to get 3D printers for home use?
Depends on what you're doing. If you're a hobbyist, maybe,
Yeah, there are some, what you'll actually find is the cheapest printers available can print just as good quality as the most expensive printers in many cases, particularly in the case of this type of 3D printing, which is called FDM 3D printing. So yeah, it really depends on what you want to put aside for that kind of stuff. A good quality 3D printer will cost about $200 now.
Yeah, it's
kind of nice.
It's extremely inexpensive compared to what it used to be. But again, it's the kind of thing that when we were working on the PPE, a lot of people wanted to help, and so they wanted to run out and get 3D printers, and so they could start printing shield frames to help out. But there's a learning curve to it, so you need to be sort of committed to learning how to use the equipment and learning to do the design. There are sites like Thingiverse where you can find a wealth of pre-existing files that you then put through the slicing software for your machines. But to really get some real use out of it, it helps to have a purpose for it, like any tool.
And is there anything else you'd like to tell us about the lab, or anything else that kids can do when they visit?
I hope that people will visit. I hope you'll go to our website and go to our contact page and schedule a visit. I'm happy to answer questions. Anybody can email me. It's terry@ffcdi.org. Always happy to chat with teachers and students. Very happy to help schools get the first programs going in their schools. We've got Marissa right here, who is always happy to help with that. We have Roboticon coming up on November 6th through the 21st, which will all be online and live streamed to YouTube and Twitch. So there's information about that at roboticon.net. A lot of that will be streamed from here as well, as teams do, individual matches, and then we record and show those. So we're always happy to work with schools that are interested in implementing programs or just need help with something and to augment programming.
Okay, thank you, Terry. Thank you, Terry. And you did mention you were giving away a 3D printing certificate. So how would you like to give that away today?
Oh my, so there's a couple of things. We went over a lot of different things. If the person who can tell us the difference between the resin printer and first response resin printer and the FDM printer, at least one difference between them, will get a 3D printing coupon worth 15 hours of 3D printing, more or less. Whatever it takes to do your project.
Get those answers coming in.
And
you can go ahead and answer in the question and answer box.
And I can't see them, so you're going to have to, I don't know if I can, I tried before to see if I could see the questions, but I don't think I can.
If you scroll down to the bottom on the right.
Maybe I didn't scroll all the way down. Oh, there they are.
And while we're waiting, Chris and Terry, do you want to maybe go over, what you, maybe what you learned to get into this field, or why you got into the field that you're in, and what for Chris, why it interested you so much?
Well, I'll actually start, and I'll give it over to Chris, but I want to say I am actually a writer and photographer by trade. But I think that understanding technology is vitally important to everyone. I need to understand how programming works and how the current technologies work. You can have a lot of technology, we all do, and if you don't understand how it works, it owns you. You don't own it. So I think to have some command and power in your life, I think you need to understand these processes. And so for me, having this type of facility, watching the processes go into reverse engineering, a product is fascinating. It helps me understand how the world works and how production works. Chris can give you a different answer because he's involved at a far more technical level. But what got you interested? And it's probably robotics, right?
Yeah, for me, actually, it was the first robotics program, actually, to be honest, that really got me most interested in, all of this. I was always kind of interested in most of the stuff, but I don't think I would have gotten as far as I did without that program. And after that, it's just been, interesting to figure out how all stuff works.
I think we would both say indulge your curiosity. There is nothing cool about not being curious. And ask questions, wonder out loud, explore things and try things out.
Yes, and I was going to ask your advice for students that are interested, but that sounds like really great advice. Is there any other advice you'd give students that are interested in 3D printing or interested in, learning about technology other than coming down to the AMRoC Fab Lab?
A lot of this, we have a resource page on the AMRoC website, resource directory and library, has a ton of free information about where to get courses and information and basically free access to learning a lot of the stuff that goes on here. This stuff is not, it takes time to devote yourself to it and really educate yourself on some of it, but it's available for you. It's free. It's there. A lot of the information on, learning Autodesk and SolidWorks is available to students at no charge, whether you do it in your school or not. Highly encourage students to get involved in a robotics program. Or a tech club of some kind, and really have a good time, trying things out and building things. The more you make, the more capable you become.
And Terry, we did have a question come in about, are there jobs available at the lab?
No, so we're a nonprofit. I wish we had more jobs because I could use more help. But right now we do have a lot of volunteer opportunities. So there's a volunteer tab. Eventually, I hope post-COVID, we'll be able to, bring on some additional staff. But right now, we don't have any paid positions available.
Okay, and can you go over your the URL for your website again and your email? Because for the answer to your question, if you have the answer, you can also feel free to email Terry, and we'll go through those answers to get that winner for the 3D certificate. So if you could please give your email address and your website again.
My email address is Terry, T-E-R-R-I, at FF, that's F as in Frank, 2 F's, ffcdi.org. And the website for AMRoC, which you can also reach me through on the contact page, is AMRoC, AMRoC, TampaBay.com. And there's the information there for you.
Perfect. And you can also feel free to reach out to us at BAMA. If you have any questions, we can pass that on to Terry. And if you have your answer to her question to win the 3D certificate, you can also email us at admin@bama-fl.org, or just go onto our BAMA website. And we have some information there as well.
And we will help you design your
out.
If you have something you want to do, we'll help you design it. So.
Okay, wonderful. And to close out, Terry, do you have any closing comments?
No, thank you. We're really grateful for the opportunity to share AMRoC, virtually and in real life. So thank you very much. I'm grateful for the students that joined us. Always happy to chat. Happy to reach out anytime. And keep going on the tours. Keep learning everything you can, and stay curious.
Well, I'd like to thank you all for being with us today and showing us around. I'm sure everyone can't wait to go and get there in person to experience all the different technology that you have. So thank you again, Terry, for taking out the time this morning, and for everyone at the lab. And I'd like to remind you that we do have programming all month long on the Manufacturing Month Hub. So check back often. We will be uploading, different videos throughout the month. And if you missed one, don't forget that we do have them on demand. So you can go ahead and, check it out. Check out the ones we've done previously as well. But thank you again, and have a good afternoon.
Thank you. Bye-bye.
Bye-bye.
Bye-bye.